Okay, friends, so I am going to walk through how to do the problems on this assessment. And as is always the case, you are never expected to watch the entire video, just the portion that you need. And I will try not to skip steps. Okay, so this first equation, because this right here is a number 4, that is going to make this a quartic polynomial, which means it will have as many as 4 solutions and 3 changes in direction. So whatever the highest power is, that tells you the name and how many solutions it will have. And then if you take the number of solutions minus 1, it will tell you how many times it changes directions. In other words, if we were to graph this, not really certain how it would lay out, but it would be something like this. Okay, it would be something like this. And it would have the x-axis in it. And it would intersect the x-axis once, twice, 3, 4 times. So that would be its 4 solutions. And then it would change direction here at this minimum, change direction here at this maximum, and change direction here at this minimum. So it would change directions 3 times. So that's why those are the answers. Okay? The y-intercept is the constant, or the number at the end, if it's in standard form like it's supposed to be. So this would be 0, 42. And the reason that is because if you filled all the x's in with 0, the answer would come out to be 42. All right, so now we need to find the solutions. Well, we know there's going to be 4, there should be 4 solutions that we find. We have no idea what they should be. They will be a factor of 42, however. But we're not certain what they would be. So the best thing to do at this point would be to grab your calculator. And it's fine to grab your calculator. One of the standards of this course is that you learn how to use technology. Okay? And we're going to type in x raised to the power of 4. Remember, you got to move to get out of the exponent. Minus 7x raised to the power of 3. Move to get out of the exponent. Minus 7x squared. Plus 43x. Plus 42. And we're just going to hit. Now you can do one or two things. You can hit graph and wait patiently for it to grow. Ooh, it graphs really quickly. You don't have to be very patient. The other thing you can do is you can look at the table and you can look for where you have in the y answers 0. So we know one of the answers is going to be 3. We know another answer is going to be 7 because that's where the y is equal to 0. If we want to find the other ones, we could go up. So there's going to be a couple more there. There's all 4 of them. So negative 2 is an answer. Negative 1 is an answer. 3 is an answer. And 7 is an answer. Or you certainly could have just hit graph and you could have counted your spaces. Negative 2, negative 1, 3, and 7. So we're going to come here and we're going to say our solutions are negative 2, negative 1, 3, and 7. And so that is it, friends. That's all that needs to be done on that problem. We go to number 2. Again, when we look at number 2, we notice our highest power here. Our highest power here is a 4. If it is a 4, this is a quartic. That means it will have as many as 4 solutions and 3 changes in direction. Remember, if you graphed it, it would look something like this, possibly. Which means it's going to hit the x-axis once, twice, 3, 4 times. And it's going to change direction 3 times. The number at the end is a 40. So the y-intercept is 0, 40. And again, I think I will just jump right over to the calculator and put this in the calculator. So we're going to go to y equals, and we have x to the 4th power minus 2x cubed minus 13, I'm sorry, x squared plus 10x plus 40. And you again can hit graph, or you could look at the table. I'm going to look at the table because it looks like I have a pretty one, a nice integer at 1, 2, 3, at 4. I can't tell on the left if that's a nice integer at -2 or not. So I'm going to look at the table because the table is more precise. So looking at the table, that is a 0 at -2. And that's also a 0 at 4. So I know 2 of my answers are -2 and 4. The problem is I don't know what the other 2 are. So I'm going to go ahead and put those in, -2 and 4. But I'm not sure what the other ones are, so I need to find them. So how am I going to find them? Well, let me move this out of the way because I need this space. So how am I going to find them? I'm going to use synthetic division. And I'm going to start with -2 because I know that's one of my answers. And then remember, when we do synthetic division, friends, we take the lead coefficient, which is right here, and the coefficient of the x to the 3rd power, and the coefficient of the x to the square, and the coefficient of the x, and the constant. We take all those numbers, and remember, if you don't see the number, it's a 1. So I'm going to take, I guess I'll do that in pink. I'm going to take the 1, and the -2, and the -13, and the 10, and the 40. I'm going to put them right here. I'm going to leave a space. I'm going to put an equals bar, and I'm going to bring the first number straight down. And from there, I'm going to multiply and add, and multiply and add, and multiply and add. Why is that green different than normal? I like that green better. So I'm going to take -2 times 1 and get -2. And then -2 and -2 are -4. And then I'm going to take -2 times 4 and get 8. And -13 and 8 are -5. And I'm going to take -2 times -5 and get 10. And 10 and 10 are 20. And I'm going to take -2 times 20 and get -40. And -40 and 40 are 0. Winner, winner, chicken dinner. We knew we were going to get a 0 because we have no remainder. Okay, we know our other answer is 4. So we are going to take the number 4, and we're going to take the number 4, and we're going to put it right here. We're going to put number 4 in the box, and we're going to continue synthetic division, but only with these numbers right here. So the first number comes straight down, and then I'm going to multiply 4 times 1 and get 4. I'm going to add -4 plus 4 is 0. I'm going to multiply 4 times 0 is 0. I'm going to add -5 and 0 are -5. I'm going to multiply 4 times -5 is -20. And -20 plus 20 is 0. Excellent. I knew that would also be the case. But here's what I'm left with. I'm left with x to the 2nd minus 5 equals 0. You're like, what? Okay, so these numbers I was left with, this is x to the 2nd plus 0x, 0x minus 5 equals 0. That's what I'm left with. Okay, so if that's what I'm left with, here's my equation. I'm going to solve it. So x squared is going to equal 5. Then I'm going to take the square root. And I'm going to have and plus and minus the square root of 5. And there are my 4 answers. So my answers are negative 2, 4, and negative radical 5 and positive radical 5. If you look back at your graph, and we look at the graph, and we actually blow the graph up so we can see it a little better. I didn't mean to hit that. I meant to hit this. If we made this negative 3 and 5, if we enlarge the graph, let me enlarge the graph even more than that. Okay, if we enlarge the graph even more than that, negative 3 and 3, and let's go back. If I enlarge the graph even more than that, then the one place that it hits on the left is negative radical 5, which is approximately negative 2.2. And then it hits at negative 2. And then it hits at positive radical 5, which is approximately 2.2. And then it hits again at 4. Okay, so that's where you could see it. Now, by the way, since we've messed with our graph, I'm going to go back. I'm going to hit zoom, and I'm going to hit 6, and it'll go back to normal. All right, that's number 2. Okay, number 3. Okay, number 3. All right, so this is a power of 3. Because it is power of 3, that is a cubic. Okay, it has as many as 3 solutions and 2 changes in direction. In other words, it's the one that looks like the S-curve if you turn your head 90 degrees. It looks like this, and the x-axis, bang, bang, bang. Might hit it 3 times, might hit it right there, and then it will change direction at this maximum and at this minimum. Okay? There is no number right here, so the intercept is 0, 0. And by the way, if the intercept is 0, 0, one of the answers of the 3 has to be 0. Because if it's going to hit the x-axis at 0, 0, or if it's going to hit the y-axis at 0, 0, it's going to hit the x-axis at 0, 0 also, which means that this point right here is not only the y-intercept, it's also the x-intercept, okay? All right, now we need to find the other 2 answers. So we can do one of a couple of things. Me, personally, I would factor it. If it was me and I was doing this problem, I would factor it because it is fairly simply factorable, and it's pretty straightforward as a factor. So to do it as a factor, if we have x to the power of 3 minus 9x equals 0, a greatest common factor would be x. That would leave me x squared minus 9 equals 0. Then I would have x squared minus 9 equals 0. I'd also have x equals 0. But that's the answer we already have. That answer right there is the answer we already have. Okay? So then if I continue to solve this other problem, x squared would equal 9, which means x would equal a positive and a negative 3. So we would say and plus minus 3. So that would be one way to do it. The other way you could do it, friends, you could go back and put it in your calculator. And if you put it in your calculator, then it is x raised to the power of 3 minus 9x. And if you hit graph, you see that it's at negative 3, 0, and 3. Okay, so you don't have to factor it. It is factorable. I think factoring is faster than the calculator, but you probably think the calculator is faster than factoring. It doesn't matter. Get it right. Okay, number 4. Come on. There we go. All right. Number 4, again, we have 5 powers. I'm sorry. Hello. We have 3 powers, which makes it a cubic. And as soon as we know it's a cubic, we know that it might hit the x-axis in 3 places, and it will have 2 solutions because it is going to be an S-curve, 1, 2, 3 intersection points, and that relative maximum and that relative minimum will provide the changes in direction. Okay, this time we have a number at the end, which is negative 32. So the y-intercept is 0, negative 32. And we need to find the values of x. This one is also factorable. So I would probably, again, if it was me, I'd factor it. There's a chance you guys would prefer not to factor it. If I factored it, it's x to the third power plus 8x squared minus 4x minus 32 equals 0. If we look at these two, and we look at these two have x squared in common, these two have negative 4 in common. So we would have x squared, x plus 8, and we'd have negative 4, x plus 8, and that would give us x plus 8 and x squared minus 4. And if x plus 8 equals 0, then x is negative 8. And if x squared minus 4 equals, equals 0, then x squared would equal 4, then x would equal positive and negative 2. So the answers would be negative 8 and plus minus 2. If you don't want to do it that way, and I certainly understand, people don't like to factor. I get it. I was once your age, and I did not have a very good number sense at the time, and I couldn't think of factors, and I certainly can look at those and see that I broke them into two pieces. So if you don't do it that way, that's fine. Go back to your calculator. Go back here and go, which one are we doing? Number 4, x to the third power plus 8x squared minus 4x minus 32. And if you want, you can hit graph. And you can see them. Negative 8, negative 2, and 2. If you want to look at the table to see if you're right, go up to negative 8. You'll see at negative 8, the y value is 0. Go to negative 2, the y value is 0. Go to 2, the y value is 0. Do I care which way you do it? No. You do need to become good at factoring though, friends. All right? Not everything can be done by looking at the picture. But if you can, you can. That's awesome. All right, number 5. Come on, there we go. Okay. So, this has 4 powers. That makes it a quartic. Quartic, just like quarter, quartic, 4. That means it's going to have 4 solutions, possibly 3 changes in directions. It's going to take on that W shape. Okay, it's going to take on that W shape. It's going to hit 4 times, have 3 changes in direction. Alrighty. Friends, why do I point that out? Because at some point in time, we're going to graph these, and you're going to need to have an idea what they look like. All right. The y-intercept. Okay, so I just want to say, on your tests, a lot of people put the y-intercept was 0.81. It is not an 81, my friends. It is a negative 81. It is 0, negative 81. You need to use the sign. You need to use the sign. Okay, again, if it was me, I would factor this. I would say x to the 4th minus 81 equals 0 is the difference of 2 perfect squares. X squared plus 9 and x squared minus 9. If x squared plus 9 equals 0, then x squared minus 9 equals 0. X squared would equal negative 9. x squared would equal 9. If you put a square root around this negative number, you are going to get x equals a positive and a negative 3i. If you do the other one, you're going to get x equals a positive and a negative 3. So your answers are plus minus 3 and plus minus 3i. Now let us say that you're a person who didn't want to factor. Let us say that you're a person who picked up your calculator, which is, again, absolutely 100% fine. I had no issue with you using your calculator. Please use your technology. It's one of the things you're supposed to learn how to use in this class. So if you used your calculator, then in your calculator you put, which one are we doing? That one. You put x to the power of 4 minus 81. And when you hit graph, you were expecting to see 4 places, but it only hit at 2. It only hit at 2, and it looks like it hits at negative 3 and positive 3. And of course, if you're uncertain, you can check. And right here at negative 3, the y value is 0. And right here at positive 3, the y value is also 0. So those are 2 of your answers, but you're 2 answers short. So then, if you're 2 answers short, then you need to go to synthetic division. And when you do synthetic division, you need to remember that x to the 4th power plus 0x third plus 0x squared plus 0x minus 81 is really the question. All those powers have to be provided. All of those powers have to be provided. And then when you do synthetic division, the lead coefficient is a 1. This coefficient is a 0. This coefficient is a 0. This coefficient is a 0. And this is a negative 81. And we know one of our answers is, let's do the negative one, Mrs. Leonard. One of our answers is negative 3. It doesn't matter which one you do first, friends. So if you put negative 3, whoops, be consistent. If you put negative 3 here, and you put 1, 0, 0, 0, negative 81 here, your space, leave a space, bring down the first number, and then do the multiplication, you're going to say negative 3 times 1 is negative 3. Add, you get negative 3. You get negative 3. Negative 3 times negative 3 is 9. Add, you get 9. Negative 3 times 9 is negative 27. Add, you get negative 27. Negative 3 times negative 27 is positive 81. Add, you get 0. Fabulous. And we knew that would be an answer. But now we're going to do synthetic division with our 3. So we're going to put the 3 in the box. We're going to leave a space. And we're going to pull the first number straight down. First number straight down is a 1. And then we're going to multiply. We're going to take 3 times 1 and get 3. And when I add, I get 0. And we're going to take 3 times 0. And 3 times 0 is 0. And when I add 9 plus 0, I get 9. And then I'm going to take 3 times 9. And 3 times 9 is 27. And when I add, I get 0. And then remember, I had a 1 here, correct? And what that means is I have an x to the power of 2 plus 9 equals 0. The 1 comes here. Here, this is how we did this the other time. This is going to be way too fat of a pen. Let me come down here. We had x to the second plus x plus 9 equals 0, which gives us this purple equation. So then when we solve the purple equation, now my pen's going to be too small, we would have x squared equals -9. Then we have to take the square root of this and this, and we get x equals a positive and a -3 imaginary number. And that's where your 4 answers are. Number 6. Okay. First of all, if it is true, how do we want to do this in? Let's do it in purple. If it's true that, let's do it in pink. X minus 3 is here. Then we're going to take x minus 3 and set it equal to 0 and get x equals 3. So this answer is either going to be 3 or it's going to be the ordered pair 3 something. But I know that. I'm going to put that there so at least I get some credit. Then I'm going to take the number 3, put it in the box, and then I'm going to do synthetic division. And again, I'm going to remember that synthetic division uses the coefficient of this number, the coefficient of this number, the coefficient of this number, and this number. So for my synthetic division, I have the number 1, the number -10, the number 28, and the number -12, because this number that you don't see is a 1. I'm going to put my equals bar. I'm going to leave a space. And I'm going to multiply. Got to bring the first number straight down. Bring the first number straight down. It's a 1. Now I'm going to take 3 times 1 and get 3. -10 and 3 are -7. I'm going to take 3 times -7 and get -21. 28 minus 21 is 7. Did I mess this? Oh, no, I didn't. And then I'm going to take 3 times 7 and get 21. And -12 and 21 are 9. So I have a remainder. So if I have a remainder, this answer is x squared minus 7x plus 7 plus the remainder of 9 with the fraction bar of x minus 3. And that's exactly what I'm going to type into Canvas. I am not, because I'm tired of driving Mrs. Leonard crazy, I am not typing that 1. Because we don't do that in Algebra 2. We've grown past pre-algebra. So we have x raised to the second power minus 7x plus 7 plus 9 being divided by the binomial x minus 3. So this is the answer, no. And because this is the number 9, it's going to go right here. It's going to go right here, comma 9 as an ordered pair. So that ordered pair came from this 3 and this positive 9. All right, 7. We're going to set it up exactly the same way. I am going to remember that if I have x plus 6, that means I have x plus 6 equals 0, so x is -6. So this is either going to be -6 or -6 comma something. I am then going to look at my coefficients of my variables and my constant, and I'm going to do synthetic division. And I'm going to say -6 is in the box. Why did I choose to go with, I thought I was doing pink. -6 goes in the box. And 1, because if you don't see the number here, it's a 1. And 9, and 26, and 48. Bring this down. 1. -6 times 1 is -6, plus 9 is 3. -6 times 3 is -18. Plus 26 is 8. -6 times 8 is -48. And this is 0. So this answer is yes. And this answer remains -6. Then all I need to do is write my quotient. And my quotient is x squared plus 3x plus 8. And I am not writing the 1 in front of that x squared because I am a big person now. I'm a big kid now. And I know not to do that. So I'm going to write x to the power of 2 plus 3x plus 8. That is it. And if there is not a remainder, don't put plus 0 divided by x plus 6. That's also annoying. All right. Okay. Number 8. So, if this is my divisor, I am going to take x plus 4, set it equal to 0, and find out that x is -4. That means this is going to be -4 or -4 something, because I don't know yet if my answer is going to be yes or no. Then I'm going to remember that I have a coefficient in front of x cubed, a coefficient in front of x squared, a coefficient in front of x, and a constant. And I'm going to write those. So I have a -4 in the box, and a 1, and a 9, and a 26, and a 48. The -4 is in the box. The first number comes straight down. -4 times 1 is -4. 9 minus 4 is 5. -4 times 5 is -20. 26 minus 20 is 6. -4 times 6 is -24. 48 minus 24 is 24. I have a remainder. I have a remainder of 24. So that ordered pair is -4, 24, and this answer is no. Now I need to write my answer. And this is x to the, what was my highest power? X to the second plus 5x plus 6. Whoa, don't know why I wrote the 6. Plus 24 divided by come on, you need to copy it, not paste. X plus 4. And so that's how we're going to write our answer. And of course, we are not going to write this one. We're going to say x raised to the power 2 plus 5x plus 6 plus 24 divided by parentheses x plus 4. That is it, my friends. All right, number 9, another division problem. Okay, yep, another division problem. So, If that is x minus 3, then the equation is x minus 3 equals 0. So the solution is 3, possibly. Okay, so we are going to take the 3. And we are going to say that this is a 4, this is a negative 13, this is a 6, and this is a 9. So we're going to go 4. Uh-oh. Wah, wah. Wah, 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 wah. Right in here, we are missing something. We are missing a 0x squared. We are missing a 0x squared. We are missing a power. All the powers have to be visible, and we are missing a power. So when we go and we look at our coefficients, we have a coefficient of 0 and a coefficient of 6. Well, that didn't make much difference, Mrs. Leonard, because your marker's so fat. All right, we have a coefficient of 0 and we have a coefficient of 6. So we need to be sure when we write our numbers. We have 4, negative 13. Let's go back to large, please. Negative 13, 0, 6, and 9. Now that is way too fat now. Let's smaller. Thank you. The number in our box is 3, 4, negative 13, 0, 6, and 9. Third power, second power, first power. Okay, yes, this works. Just making sure everything was there, friends. First number comes straight down. Then we're going to multiply. 3 times 4 is 12. Minus 13 is negative 1. 3 times negative 1 is negative 3. Plus 0 is still negative 3. 3 times negative 3 is negative 9. Plus 6 is negative 3. 3 times negative 3 is negative 9. That comes out to be a 0. By the way, this was a 3, right? Yeah. Okay, so that's a 3 and this is a yes. And if our highest power was 4, our first answer is going to have a 3. So we made that really big. Let's make it smaller. So this is going to be an x to the power of 3. This is going to be an x to the power of 2. This is going to be an x. So our answer is going to be written as 4x to the power of 3 minus, and we are not writing the 1, minus x to the power of 2 minus 3x minus 3. And there is our answer. All right. Is there any more division? We are done dividing. Okay, now we are factoring. Okay. Step 1. Step 1. Always look for GCF. Always look for a GCF. Always look for a GCF. Each and every time. In this particular case, there is not one. There is not one. What we have, because there are only 2 terms, this is the difference of 2 squares. This is the difference of 2 squares. So I'm going to open 2 sets of parentheses, and I'm going to go x plus 8 and x minus 8. If you don't do it that way, if you do it the way of the x, then you are looking for factors of negative 64 that add to 0, because right here there's a 0x that's not showing up, and those numbers would be 8 and negative 8. So you can either do it as the difference in two perfect squares, or you could factor it by a trinomial. Okay, the next one. The next one has no greatest common factor, but it has a lead coefficient. So I am going to take, I want to put that arrow on top. It has a lead coefficient, not 1. So I am going to write 4x squared, and I'm going to write negative 16. And I'm going to ask myself, I'm going to say self. I'm going to say self, what are the factors of negative 64 that add to negative 63? And some of you are like, where did you get negative 64 from? If you take 4 and you multiply it by negative 16, you get negative 64. Okay? And the answer to this is 1 and negative 64. That is the factors of negative 64 that add to negative 63, but that's not the solution. And a lot of you on the test made that the solution, and it's not. What it does do is right here, it gives you a 1x squared and a negative 64x. And I didn't mean to square on that. That's what it gives you. So the people who got the negative 64 and the 1 on your test, but you got it wrong, it's because you didn't split the middle term. You just wrote those as your answers, and that's not right. Okay, so then we're going to look at this pair, and we're going to look at this pair. And the first pair has an x in common, and the next one has a negative 16 in common. And so we're going to pull out the x, and that's going to give us 4x minus 1. And we're going to pull out the negative 16, and that's going to give us 4x minus 1. And so our factors are going to be 4x minus 1 and x minus 16. Now, if you don't know the factors of 64 off the top of your head, which is fair, no shame. Oh, timed out. It's been too long since we used the calculator. You would go into your calculator, and we're looking for factors of negative 64. So you would say y equals negative 64 divided by x. And you got to use the negative sign, friends. You can't use the minus sign. And what that does is that asks the calculator to divide negative 64 by every number in the whole wide world. And if you look at the table, that is 64 divided by every number in the whole wide world. Well, actually, divided by every integer in the whole wide world. So those are just all the ways to get to negative 64 through multiplication. But you need to know which ones add to a specific number. So you're going to ask your calculator to add those together, to add the x and the y column together. And we're looking for a negative 63, and it's always in the red column. So you look in the red column for a negative 63. Right there in the red column is the negative 63, and the numbers were 1 and negative 64. So that's how you do that if you don't own the factors. All right. So that's that one. Let's move on to number 11. Okay, number 11. Before we do anything, we are always supposed to look for greatest common factor. The very first one there is not. Okay? And I purposely made this come out to be negative 64 because I knew some of you would already have in your calculator the factors of negative 64. So now we're looking for a red 12. So now if we go back to that list, now we're looking for a red 12. That's a negative 12. We want a positive 12. I don't know why I went the wrong way. So there's a positive 12. So those numbers are 16 and negative 4. So 16 and negative 4. So 16 and negative 4. So 16 and negative 4. And just like that, you're done. Oh, and this one you actually have. This one we did a moment ago. This one really is this time x plus 1 and x minus 64. Okay? All right. Moving on. Okay, when we go to do these, before you do anything else, you are always supposed to look for a greatest common factor. And in the first one, which I think I'm using the green for, this is divisible by 4, and this is divisible by 4, and this is divisible by 4. So when we do that, we divide out the 4, and we have x squared minus 2x minus 15. And then we look for factors of negative 15 that add to negative 2. And they are negative 5 plus 3. So we have x minus 5 and x plus 3. In the next one, we always look for greatest common factor. These have a 3x in them. So we have 3x. And that gives us x squared plus 3x plus 2. So this is 3x, and this is x plus 2, and x plus 1. Alrighty. Moving on. Okay. F plus G. So we are going to take F. Well, let's get larger than that. We're going to take F, and we are going to, maybe not that large. We're going to take F, and we're going to add it to G. So when we take F and we add it to G, and I guess I'll write this out because people missed it, and truly friends, truly friends, we should not be missing this problem. This was one that I counted on everybody to get right. So in the future, everybody get it right, okay? Because you guys have the skills. You would not be in this class if you did not have the skills to do this problem. You just wouldn't. I mean, that's just the way it is. Line them up, just like that. Put the equals bar. And combine them. So we got 3x squared minus 7x minus 4. 3x to the fourth power. Whoops, to the second power. Mrs. Leonard just making things up now. Minus 7x minus 4. Okay. That's that one. The next one, we are going to take, and we are going to take, what do we have? We have GH. We're going to take G, and we're going to multiply it by H. So we're going to take G, and I'll write this out. We're going to take G, which is negative 2x plus 8 times H, which is negative 4x squared plus 3x minus 8. And we're going to distribute. We're going to take negative 2x, and we're going to take negative 2x times each term. I don't like that I'm in the answer box, so I'm going to slide this down. And when we do that, I'll write it in blue. You get 8x to the power of 3 minus 6x to the power of 2 plus 16x. Then we're going to take 8 and we're going to multiply it by these 3 pieces. And 8 times -4 is -32, x to the power of 2. 8 times 3 is 24x, and 8 times -8 is -64. And friends, we're going to make sure that our powers line up. Those are both squares. Those are both x's. So we're going to line up our powers, and we're simply going to combine what we wrote. Maybe you guys think better with combine than add and subtract. I don't know why, but it's fine. Let's combine what we have. If we combine what we have x to the power of 3 minus 38x to the power of 2 plus 40x minus 64. And so we write that in Canvas, 8x to the power of 3 minus 38x to the power of 2 plus 40x minus 64. Okay. And friends, we have those because that's everything we did to do factoring and such, and to write polynomial functions. All right. So actually skills that you had last year. The first one here is F plus H. We did the first one in pink. Yep. The first one is F plus H. So let's do F plus H. So F plus H. This is F right here. And this is H right here. So we are literally going to take this one, write it down, and then we're going to take this one, write it down right underneath of it. There they are. Put our equals bar and combine them. And when we combine them, we have negative x squared minus 2x minus 20. So we have negative x to the power of 2 minus 2x minus 20. Do not write a 1 in front of the x squared, and remember you have a negative number. All right, then the next one is f minus h. So f minus h, oh, I should have left those things. Well, I have one of them, this one. There's the h. There's the h, right? Now I need the f. And the f. And here's the f. But here's the issue with this, friends. The issue with this is it says minus. We were doing this in, let's do it in purple. This right here says minus. So we have to take all of this and subtract it. All right, so what we really have is we have f, which this is f. And what we really have is a 4x squared and a negative 3x, because I want the opposite of this and the opposite of this and the opposite of this, plus 8. Now we put our equals bar, and now we have 7x squared minus 8x minus 4. All right. G plus J. G plus J. So right here is G, and right here is J. We add those together. Negative 2x and 4x is 2x. Wrong color. Negative 2x and 4x is 2x. And 8 minus 9 is negative 1. The next one we have is G which is this one, multiplied by f, which is this one. So we have negative 2x plus 8 being multiplied by 3x squared minus 5x minus 12. We are going to take the first term, which is negative 2x, and we are going to multiply it by each term in this function. So negative 2, negative 6x raised to the power of 3, plus 10, x gets raised to the power of 2, plus 24, and now you have an x. And then you're going to take your 8, and we're going to multiply each of these numbers by 8. So that's going to give us 24x to the power of 2 minus 40x minus 96. And then we are going to combine or add, however you want to think of it. We are going to combine, and we are going to get negative 6x to the power of 3 plus 34x to the power of 2 minus 16x minus 96. Negative 6x to the power of 3 plus 34x to the power of 2 minus 16x minus 96. Alrighty. Okay. How far from the point where the arrow was shot to where it landed? No, the height of the arrow when it leaves the bow. The height of the arrow when it leaves the bow. The height of the arrow when it leaves the bow. The height of the arrow when it leaves the bow. That goes right there. After 8 seconds. Okay, so after 8 seconds. So we are going to take the original problem, and we're going to say what happens if I substitute in an 8. So I have negative 16, 8 to the power of 2, plus 152 times 8 plus 7. So that's what I'm going to type into the calculator. And so in my calculator, I am going to go, and I'm going to go with negative. You got to use the negative, not the minus, my friends. 16 parenthesis 8 parenthesis squared plus 152 parenthesis 8 plus 7, and hit enter and get 199. And so my answer is 199. Now I don't know the next answer yet, so I'm going to wait. Okay. To the nearest hundredth of a second, how many seconds will it take the arrow to reach its maximum height? If we go all the way back up here to the directions, right up here in the directions, I'm going to copy this and bring it down. In the directions, copy. Sorry, don't get dizzy. Okay. So, of this, to answer this question, I'm going to use, of this, I'm going to use this portion right here. I am going to say T, whoops, let's use pink. T will equal the opposite of 152 divided by 2 times negative 16. So that is 152 divided by 32. So 152 divided by 32 is 4.75. So I want to put in 4.75, yes, and it says to the nearest hundredth, so that's what I want, 4.75. Okay, so here's the deal. If it reaches its height at 4.75 seconds, then this must be falling. 8 seconds happens after 4.75. So that has to be falling. Okay, so now I'm going to take this number right here and I'm going to put it in the original equation. All right, so I am going to say h of 4.75 is equal to negative 16 times 4.75 quantity squared plus 152 times 4.75 plus 7. I'm going to go grab my calculator. And I am going to type negative 16 parentheses 4.75 close it square it plus 152 parentheses 4.75 close it plus 7 and hit enter and get 368. And so I hit enter and I get where's my pink pen? 68. Okay. So now, I'm going to take this problem right here, and I'm going to go right here, and I'm going to say, maybe we'll do this in green, that this is A, and this is B, and this is C, and I'm only going to use the negative portion, and I'm only going to use the negative portion because it looks like this. And the x-axis is here, and the y-axis is here. Actually, the y-axis probably pulled over some because this is 7 feet off the ground, and this is supposed to be, what was our answer? 199? No. Yeah, 100, maximum height 368. So this picture isn't very good, okay? Whatever. But my point is, this part over here we don't care about. Okay, so we're going to use the negative portion of this. And so we're going to have, let's do it in blue, I guess. Oh, we'll do it in green. X equals the opposite of 152 minus the square root of 152 minus 4 times negative 16 times 7, all divided by 2 times negative 16. So in my calculator, that's exactly what I'm going to type. So in my calculator, I'm going to open a parenthesis, and I'm going to say negative 152 minus the square root of 152 squared minus 4 times negative 16 times 7. Got to get out of the square root, close my parenthesis, divided by negative 32. And I get 9.545, 9.545, 9.545, 9.545. And what do I want to round it to? To the nearest tenth of a second. So 9.5 seconds is that answer. All right, my friends. Okay. Let's do this in their colors. This is a constant. Yes, it is a line, but more specific, it is a constant line. That should not have gone there. Sorry, I didn't see. I was not in the first space. My bad. And I'm a little small. This is a constant. I know it's a constant because if I look at the graph, it's a horizontal line. If I look at the equation, there's no x. So if there's no x, it has to be a constant. That's the definition of a constant. Blue is a quadratic. I can tell it's a quadratic by its shape. And if I can't tell it's a quadratic by its shape, right there, its highest power is 2. The next one is linear. And if I can't tell it's linear by its shape, the highest power of x is 1. And the fourth one is a quadratic. And if I can't tell it's a quadratic by its shape, the highest power of x is a 2. Okay? The domain goes from negative infinity to infinity. How do I know that? Well, there's a couple ways to know that. The first way is, even though the graph is broken, it goes from left to right without missing anything. The other way to know that is if you look at these, this starts with the lowest x imaginable, and this ends with the largest x imaginable. And there's no x's missing. This goes to negative 11. This goes to negative 11 to 1. This goes from 1 to 8. And this goes from 8 up. So there's nothing missing. So it's all there. So it's all there. So it has to be negative infinity to infinity. Okay. People, when we write x-intercepts, we write the entire thing. And when there is a list, we put a comma, and then we do the next one, 0.127, comma, 0. And then between the last two answers, we use the word and. And we put 17,873, comma, 0. Okay, I get that that's hard to remember. I do have to admit I'm struggling with the not remembering it, since that's been the rule since August 30th. Or whenever the school year started, August 15th. But nonetheless, when I graded your test, if you had all the answers and your form was wrong, I gave you credit for it anyway. But that is exhausting, guys. All right, and this is 024. 024. And by the way, and this was a question that tons of people asked me, the word intercepts. Why did I use ink and not a highlighter? The word intercepts means that you're going to have an ordered pair. It's a location on a graph. So you have to have an ordered pair. All right. So now, I'm going to show you something on your calculator that I've not shown you before. And I didn't show it to you before because some of your calculator skills were really, really, really poor first semester. But you guys are getting better with your calculators, so I'm going to show you this. All right? We're going to go to y equals, and we're going to clear what's here. And we're going to put in what is in this problem. The very first equation is just the number 3. The next one is negative x to the second power minus 10x plus 24. The next one is negative 4x plus 12. And the last one is 1/3 x, whoa, what did I do? X minus 14 squared minus 5. Okay? So that is everything that's in the question. All right? That's everything that's in the question. Now we're going to do this. This is where you're going to be amazed. We are going to go to second and table set. And we're going to go down here to the word ask. The very first ask. The first one, not the second one. We're going to change it to ask, and we're going to hit enter. Okay? Well, you know what? Before we do that, just because I want you to see this. So here's the graph of all those graphs. And of course you can't see it because it's all out. I shouldn't have done that. Okay, so table set, change it to ask. Now when you look at the table is empty, right? See the empty table? Okay, the questions in the problem are negative 30 and negative 18 and negative 12 and negative 11. I'll probably stop there for now. Okay, so those are the first 4 questions. All right. If we go back and look at this, this information right here says for all the x's that are smaller than 11, we're going to use this function. So for these 3 questions right here, we are using this line. And the answer is 3. So we're going to put 3 here, here, and here. And if you look at your calculator, in the Y1 row, the blue row here, all the answers in this row are 3. Meaning the blue function, no matter what the number is always going to be 3. And we just use the negative 30, the negative 18, and the negative 12 because the information says don't use negative 11, it's too big. All right, so then if we go back to our picture, blue, this piece right here says, oh, you're using highlighters, Leonard. This piece right here says between 11 and 1. So no smaller than negative 11, no bigger than 1. So it turns out to be these 3 right here. So these 3 right here are going to go into this function, okay? Which when it matches up with your calculator, it's the second function you put in. So it's the second answer. So negative 11, negative 3, and 0. So if we look at this, at negative 11, the red answer is 13. And then the next one we wanted is 3 and 0. So 13, negative 15, and 24. 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 And the 24 makes sense because it was right there anyway. Okay? All right. The next one, which is in purple, says everything between 1 and 8, but don't include 1 or 8. So that would be these 2. So these 2 right here are on the line, are on the linear function. These 2 right here go into this. This is the third one we put in our calculator. And we want to test 5 and 7. So let's go to our calculator. And let's ask our calculator for 5 and 7. And we got to be in the Y3. So 5 and 7. Did I not hit the 5? Let me try again. 5 and 7. Why is it not doing the 5? 5. Okay. So 5 is negative 8 and 7 is negative 16. I don't know why those are backwards. 5 is negative 8 and 7 is negative 16. 5 is negative 8 and 7 is negative 16. Negative 8, negative 16. Negative 8, negative 16. How's my memory? Negative 8 and negative 16. Well, I can look and see if that makes sense. When this is 5, that would be there. And what was the other one? 7. And that would be there. That would be about negative 8 and about negative 16. That makes sense. Okay, that works. And then the next one, do we really want to highlight in black? How about not? How about orange? We'll do the highlight in orange. This is anything bigger than 8. So anything bigger than 8, that's these 2 right here, 11 and 23. So 11 and 23, and this will be the last function in our calculator. So 11 and 23. So 11 and 23, so we're going to ask it about 11. So we're going to say, what about 11? And the answer is negative 2. Let's put it in there before I forget. Not that. -2. And then 23. Let's put 23 in here. And for 23, the answer was 22. The answer was 22. Okay. Now, you could have done them the way that I showed you to do them last semester. Okay. I'm going to take this out. So we need to change it back from ask, guys. So that's going to drive you crazy. Go back to auto. So see, when you're in auto, it will just give you the... I thought I put it on auto. Did I not? I did. Let's have it start at 0. And we're at auto. Yeah, and now it just gives you all of them. You know, like this. But it's nicer just to ask them things than to move to it. All right. It doesn't matter. The way that we talked about doing it last semester was just typing them in your calculator and putting them in. But like the last one would be a beast, right? So the last one was, we'll just do the last one for you. The last one was 1/3, correct? Then we'd open a parenthesis, and we're going to put in 11. And we're going to go -14, close it and square it, and then -5. And that's that answer. And then we hit second enter, and we change our 11 to a 23, and that's our next answer. You can still do it that way. It's absolutely fine. Doesn't matter to me. I don't care. All right. Your choice. Okay. Are we finally? Okay. Yay. Alrighty. So, F plus T plus B equals 333. You guys are where almost everybody has this correct. Please remember this number goes in the problem because it asks for an equation. So it has to have an equal sign in. It's got to be something. The next one, F 2T plus 3B equals 673. Okay, and again, friends, do not put the 1 in front of the F. That's ridiculous. All right. Lastly, the one that's people are most challenged by. Ask yourself, there are more field goals from beyond the arc than free throws. So there are more B's. Therefore, B's have to equal the free throws plus 7. B's have to equal free throws plus 7. Because you want them to equal each other. So if you want him to have the same number of free throws as he had shots beyond the arc, he would need to go to the line more and shoot 7 more free throws. Then he could have as many free throws as he has 3-point shots. Okay? And the reason we didn't put this in a matrix is because there's actually more than one answer. And it took us at lunch discussing that to figure out that there's more than one correct answer. So, sorry about that. Okay. Friends, I don't care if you like basketball or not. I don't care if you understand the words in this problem or not. Here's what you're picking out. That we are talking about wins and we are talking about losses. Okay? We're talking about wins and losses. So we are going to write wins, losses, and total. And this is basketball, so you're only doing one of those two things. It's binary. You either win the game or you lose the game. It's not soccer. We're not tying anything. All right? It's a win or it's a loss. That's it. Okay? And as long as it's 100%, the total is 100%. We won 48% of the games we played, which means we lost 52% of the games we played, which is why James Naismith has a losing record, because he lost more games than he won. In 9 years that James Naismith was the coach of the Jayhawks, in those 9 years, they lost 60 games. Okay? So if we want to find wins, we write the equation 48 divided by 52 is equal to wins divided by 60, which comes out to be 48 times 60 divided by 52 is the number of wins. So 48 times 60 divided by 52. 48 times 60 divided by 52. But you can't have part of a basketball game. So that should be 55. So that should be 55 wins. So if we put 55 there, and we add the two numbers together, this is a 5, and that's an 11, so 115 games. Now, you say, Mrs. Leonard, I didn't do it that way. That's fine. It should still come out the same. This is probably where I'm going to be unhappy with myself for doing this again. Wins, 48. Losses, 52%. Total, 100%, 60 games. Let's find the total. So let's look for the total. If we look for the total, that is 52 100ths is equal to 60 T's, which would be 52 T's equals 60 times 100, which then we would divide by 52. So then the totals would be 6,000 divided by 52. So 6,000 divided by 52, I pray is the same number. 115. 115. So this is 115. And 115 minus 60 is 55. So no matter how you slice it, that is the answer there. All right, my friends. I hope this helps. Have a great day.